presence of current in this horizontal deflection coil will interact with the magnetic field present due to presence of electrons in the electron beam, and interaction of these two magnetic fields will cause a third force which will act on the electrons, because electrons are free particles. So, these under the effect of that force, these electrons or consequently the electron beam will tend to move horizontally in left or right direction. So, depending upon the intensity of intensity of current in the horizontal deflection coil, the electron beam will get deflected in horizontal direction. Similarly, we have vertical deflection winding. This is pair of vertical deflection winding, one is this and second is this. So, similarly, as we have current in horizontal deflection winding, we will be having current in vertical deflection winding also. So, presence of current in vertical deflection winding will be having presence of magnetic field associated with itself. So, that magnetic field which is present here will interact with the magnetic field present due to presence of electrons in the electron beam. So, these two magnetic fields when interact, what will happen, a force will be exerted and that force will be exerted on the electron beam, and under the effect of that force this electron beam will be deflected in vertical direction, that is towards up or towards right. So, it depends in which direction the current in vertical deflection winding is, depending upon that the electron beam will be deflected towards upper side or towards the bottom of the screen. Here it is more clear, this is the winding of present within the deflection yoke. These windings are for horizontal deflection coil, as we have just seen in the previous slide, and these windings are for vertical deflection coil. So, when current flow in this winding, the magnetic field will be there, here are the magnetic lines of force, and these magnetic lines of force will interact with the magnetic field. This is magnetic field of the electron beam, here this circle, this is magnetic field of the electron beam. So, this magnetic field of vertical deflection coil will interact with the magnetic field of electron beam present here. As a resultant, because of interaction of two magnetic fields, the electron beam will be deflected towards the top or towards the bottom. Similarly, we have winding in horizontal deflection coil, these two windings, this is pair of winding of horizontal deflection coil. This will also be having a magnetic field as shown by these magnetic lines of force. So, depending upon the direction of current of direction of flow of current in the horizontal deflection coil, a corresponding magnetic field will be generated, and as we have magnetic field associated with the electron beam also. So, this magnetic field will interact with the magnetic field of the electron beam, and as a result this electron beam will be deflected towards left or towards right, that is in horizontal direction. Beam deflection, I just have explained how the beam will be deflected. I just will go through this. As already stated, the electron beam must attain a very high velocity to deliver enough energy to the atoms of the phosphor coating. Because of this, the electrons of the beam remain under the influence of the deflecting field for a very short time. This necessitates the application of high deflecting field to achieve the desired deflection. It is very difficult to generate such high voltage at the deflection frequency. On the other hand, with magnetic field, it is a large current that would be necessary to achieve the same deflection. So, that is why we use, as I explained, we use electromagnetic deflection, we do not use electrostatic deflection. This is one of the reasons why we use electromagnetic deflection, because it will be feasible and possible with electromagnetic deflection only to provide such a high magnetic field. Second, since it is more convenient to generate large current than high voltages, all the picture tubes employ electromagnetic deflection. This is the another reason, because it is always convenient to generate large current than to generate high voltages. Generation of large current is more easy as compared to generation of high voltages. For this reason also we employ electromagnetic deflection in the picture tubes. With electrostatic deflection, the beam electrons gain energy, thus larger deflection angles tend to defocus the beam. Further, deflection plates need to be placed further apart as a deflection angle is made larger, thus requiring higher voltage to produce the same deflection field. Magnetic deflection is free from both these shortcomings, and much larger deflection angle can be achieved without defocusing or non-linearity, with these consequent saving in tube length and cabinet size. Because the size of the screen should be more, we want a bigger screen all the times. So, to provide such a to scan the bigger screen, we will be requiring more deflection angle. So, having to have the more deflection angle, what will be requiring that the if we use electrostatic focusing, then deflection plates are required to be placed apart at a larger distance, one thing. Second, we will have to generate very high voltages also. So, these two are the drawbacks due to which we do not use electrostatic deflection, because it is not possible to have more space for deflection plates. So, to conserve the space, what we do? We use electromagnetic deflection. One more reason what it should be expected expressed here. The beam is deflected by a pair of deflecting coil mounted on the neck of the picture tube in the same way the rate as beam scans the target in the camera tube. The amplitude of the current in the horizontal and vertical deflecting coil are so adjusted that the entire screen called raster gets illuminated because of the fast rate of scanning. Because the scanning is at a very fast rate, and we have to deflect the beam to the extreme corners of the screen. So, for that what we do, if we use electromagnetic deflection, for electromagnetic deflection we require the coils. So, those coils can be mounted outside the picture tube, whereas if we use electrostatic focusing, electrostatic deflection, then we will be required to have those electrostatic plates, those focusing the deflection plates, and deflection plates has to be placed within the picture tube. So, that will enhance or enlarge the size of the picture tube. So, to conserve the size of the picture tube, what we do, we use yoke and we use deflection coils, we use electromagnetic deflection, because the coils can be mounted outside the picture tube, and usually we mount the coils on the neck of the picture tube, and by doing so we are able to generate the high amplitude of current which is required for by the deflecting coils to give the desired deflection of electron beam. Scanning. To show the picture on the screen, we require scanning. The scene is scanned rapidly both in horizontal and vertical direction simultaneously to provide sufficient number of complete picture of frame per second to give the illusion of continuous motion. The scanning is a process performed in picture tube to convert optical information into electrical signal. The fine and sharp electronic beam is used to scan the focused image, and beam convert the optical information to electrical signal element by element and line after line till entire picture or image is scanned. Scanning of element is done at a very fast rate, and this process is repeated a large number of times per second to create an illusion of simultaneous pickup and transmission of the picture detail. This is called illusion of continuity. Scanning may be identified as a particular process which permits the conversion of information existing in space and time coordinates into the time variations only. The electrical information obtained from the TV camera tube is generally referred to as video signal. This picture shows the horizontal and vertical scanning. Here this is horizontal scanning, the raster on the raster. When the current rises, it is called trace, and when current rises, the beam spot moves from left to right as it is shown by the fair line. When the retrace occurs, means when current falls, direction of current is reversed, the retrace will occur, which is shown by the dotted lines. The beam spot will move from right to left. During this, no picture information is collected, neither it is displayed. This shows vertical scanning. When current rises in vertical deflection coil, the beam spot is experiencing a force which moves the beam spot from top to bottom. When current falls in the vertical deflection coil, what happens? It is the vertical retrace, and during that what will happen? The beam spot will move from bottom to top. So, it is shown here when current rises, this is shown here. When current rises, beam spot moves from top to bottom. When current falls, beam spot moves from bottom to top. So, this is called vertical trace and vertical retrace. Here I have shown both these sawtooth waves. This is horizontal the wave sawtooth wave of horizontal sweep oscillator, and this is for vertical sweep oscillator. So, as it is evident from here, when it is current is rising in vertical sweep oscillator, it is rising and falling in horizontal sweep oscillator, and when it is falling in vertical sweep oscillator, again then also it is rising and falling irrespective of the direction of current in vertical sweep oscillator. The current in horizontal sweep oscillator will keep on rising and falling, and during the vertical retrace, what we do, we lose 20 lines per field, and for entire frame we lose 40 lines when we do the vertical retrace. Compatibility. Now, we will discuss the color picture tube, but before that I require to get into touch with the compatibility. What compatibility means? 1. The color television signal must produce a normal black and white picture on a monochrome receiver without any modification of the receiver circuitry. This is one, that the color television should be able to display the monochrome or black and white information. Second, the color receiver must be able to produce a black and white picture from a normal monochrome signal. This is referred to as reverse compatibility, as it is required that color TV should be able to display the black and white information. Similarly, if the information is color 1 and we are having a black and white TV or monochrome TV, it should able to display the color information in its black representation. To achieve this, that is to make the system fully compatible, the composite color signal must meet the following requirement. For the compatibility, there are some prerequisites, there are some conditions which are to be satisfied. 1. It should occupy the same bandwidth as the corresponding monochrome signal. Second, the location of spacing of picture and sound carrier frequency should remain the same. Third, the color signal should have the same luminance information as would a monochrome signal have, transmitting the same scene. This is evident when we go for reverse compatibility, we require this third point. Next, the composite color signal should contain color information together with the ancillary signal needed to allow this to be decoded. Next, the color information should be carried in such a way that it does not affect the picture reproduced on the screen of the monochrome receiver. It should be able to display it in monochrome form also. The system must employ the same deflection frequency and sync signal as used for monochrome transmission and reception. Basically, we have the monochrome system and we add color to it. So, these are some of the requirements which are to be met with. Next is, in order to meet the above requirement, it becomes necessary to encode the color information of the scene in such a way that it can be transmitted within the same channel bandwidth of 7 megahertz without disturbing the brightness signal. So, this is done with the help of multiplexing. We multiplex the color information with the black and white information, and we do this within the 7 megahertz range, which is the bandwidth for the TV in 625 line system. Similarly, at receiving end of the decoder must be used to recover the color signal black in its original form or feeding it to the tricolor picture tube. Color television display tube. The color television picture tube screen is coated with the 3 different phosphors. one for each of the chosen red, green and blue primaries. As I discussed earlier also, these three colors are called the primary colors. The three phosphors are physically separate from one another, and each is energized by an electron beam of intensity that is proportional to the respective color voltage reproduced in the television receiver. As I explained earlier also, that these three spots, which are designated for three different electron guns, are for those guns separately, and each gun is made to strike on the respective spot. The objective is to reproduce three coincident raster with produce red, green and blue content of the transmitted picture. While seeing from a normal viewing distance, the eye integrates the three color information to convey the sensation of the hue at each part of the picture tube. I discussed this earlier also, that the three spots are so closely spaced that they merge into each other, and when we see it from a normal viewing distance, it appears as if these three colors have been mixed and we have a resultant color. Based on the gun configuration and manner in which the phosphors are arranged on the screen, three different types of color picture tubes have been developed. These three colors are delta gun picture tube, guns in line or precision line and trintron. First one is delta gun color picture tube. Here it is called delta gun color picture tube because these three colors green, blue and red, they are placed in this manner as if a delta. This give a delta shape. So, that is why we call it a delta picture tube or delta gun color picture tube. Here these are the three electron guns red, green and blue, and the electrons being emitted from these three guns pass through this shadow mask and through this dot triad screen, and they strike at this dot triad screen. This dot triad screen contains blue, green and red color, and depending upon the intensity of green, red and blue, a resultant color is formed. As I already have explained, that these three spots are very closely spaced. So, the resultant is the color which is hue of the combination of these three colors, and intensity of these three or proportion of these three will define the resultant color. This was developed by Radio Corporation on America. It employs three separate guns for each phosphorus. The gun are equally spaced at 120 degree, because this is 360 degree interval with respect to each other and tilted toward inward in relation to axis of the tube. They form an equilateral triangular configuration. That is why they are called delta gun color picture tube. Drawbacks of this: convergence is difficult and involves considerable circuit complexity. This is very complex circuit at all, and service adjustment. In most delta gun tubes, 4 static convergence magnets and dynamic convergence assembly are employed. The focus cannot be sharp over the entire screen because of the focus and convergence planes cannot remain coincident for the three beams which emanate from guns positioned at 120 degree with respect to each other around the tube axis. The electron transparency of the mask is very low, since it intercepts over 80% of the beam currents. Second is PIL, precision inline color picture tube. Here we have a different shape of shadow mask. So, this is the second tube, and third one is the trintron, which is called the coma effect. So, here I stop. Thank you very much for attending.